This lesson introduces some basic ideas about sets and Venn diagrams. This is a Venn diagram here. You can see it consists of a rectangle and two overlapping circles. The universal set is represented by this capital letter U here, and it denotes everything within the rectangle. So in this particular example, U, the universal set, is all of the numbers from 1 to 10. And notice that the list of elements within the set is contained within curly brackets, and each element is separated by a comma. Set A is all of the numbers contained within the circle labelled A, so that's 2, 3, 5 and 7, and set B is all of the numbers contained within circle B. That's 1, 3, 5, 7 and 9. And again notice that because A and B are sets, we have curly brackets and the elements separated by commas. Set A has 4 members or 4 elements, 2, 3, 5 and 7. There's a couple of ways that we can denote this. Firstly, we can say that NA, the number of elements within A, equals 4, or we can use these vertical lines which symbolise the magnitude of A, or the size of A is 4. So please notice the distinction between A, which is the set, and NA, or the magnitude of A, which is a number 4. Next we're going to introduce a symbol to represent is an element of. 9 is an element of set B, and the symbol here is this sort of curly E. 9 is an element of the set B. Using the same example, we can say that the number 2 is not in set B, and this is like the symbol for is an element of, but with a line through. 2 is not an element of set B. We don't have to label sets with capital letters. This is another set. Curly brackets and commas show that it's a set. So 2, 7 is a set. And because both of these elements are in the set A, we say that 2, 7 is a subset of A. The symbol for subset is like a sort of squashed C. So 2, 7 is a subset of the set A. Next we're considering a set which is not part of this example, the multiples of 4 that are odd numbers. Let's think about that. We have a set consisting of multiples of 4, 4, 8, 12 and so on. So this is the set of multiples of 4, and none of them are odd numbers. We have a symbol for that which looks like a 0 with a line through it, and this symbol is called the empty set. It's the set that has no elements. So the empty set, which can also be written as a pair of curly brackets with nothing in between them, and we can say that the number of elements in the empty set is 0, or the magnitude of the empty set is 0. So notice the difference between the symbol for the empty set, which is a set with no elements, and that's like a 0 with a line through it, and the number 0, which stands for the number of elements in the empty set. Back to our example, and now we're going to consider the intersection of set A and set B. This is the region of the Venn diagram where set A and set B overlap. And the symbol for that is this croquet hoop here, A intersect B. And we can list the elements using curly brackets and commas. The intersect of A and B is 3, 5, 7. The union of set A and set B is the region of the Venn diagram enclosed by both of the circles A and B. And it's denoted by the symbol U. A UB, the union of A and B. And the elements of the set A union B are 1, 2, 3, 5, 7 and 9. We can say that A union B is this set consisting of all of the elements that are in A or B or both. Whereas the intersect, A intersect B, is all of the elements that are in A and B. The complement of A, and notice the spelling, it's complement with an E, is denoted by A dash or A bar, and it stands for all of the elements that are not in A. So if we remove everything in set A, and that's everything in the entire circle of A, then what we'd have left are the elements that are in neither A nor B, and the elements of B which are not also in A. Notice that the intersect is also gone because the elements that are in the intersect are also in set A. So in this example, the list of elements in the complement of A is 1, 4, 6, 8, 9 and 10. And on the Venn diagram, using shading, the complement of A looks like this. Everything apart from the circle labelled A is shaded. Finally, I wonder if you can describe the sets U, A and B in words. I already described U at the beginning of this lesson as the set of numbers from 1 to 10. So can you describe set A and set B using words? In this example, I'm going to demonstrate how a Venn diagram can be used to help solve a problem. We have 36 office workers asked whether they'd drunk tea or coffee during their morning breaks in the previous 2 weeks. 7 said they'd drunk both, 8 said they'd drunk only tea, 6 said they'd drunk neither, so how many had drunk coffee? Our Venn diagram, instead of sets A and B, we're going to label with tea and coffee, and we always have U for the universal set. Now, instead of listing 36 separate people somewhere on the diagram, we're just going to put the numbers of people in each section. So to start with, we've got 7 that had drunk both. 8 said they'd drunk only tea, and 6 said they drunk neither. Now remembering that we've got 36 office workers in total, and so far we accounted for 21 of those, we must have 15 in this section. So how many had drunk coffee? If you answered 15 to this question, then I'm afraid you are incorrect. 15 is the number of people who had drunk only coffee. But in total, we've also got the 7 people who drank both. So in total, 22 people had drunk coffee in the last 2 weeks. A Venn diagram is not the only type of diagram that can help to solve problems like these. Now I'm going to work through the same example using a two-way table, which is also known as a Carroll diagram. 7 said they drunk both, so that's coffee yes, tea yes. 8 said they'd drunk only tea, that's tea yes, coffee no. And 6 said they'd drunk neither, that's coffee and tea both no. We also know that we have 36 people altogether, and we can fill in the gaps with the totals of the rows and columns. So the total number of tea drinkers is 7 plus 8, which is 15. The total in this space here is found by subtracting 15 from 36, and the total here is found subtracting 6 from 21, And then the total number of coffee drinkers is 7 plus 15, which is 22. Total number of people who didn't drink coffee, 8 plus 6 is 14. And to double check, 22 plus 14 does equal 36. This is a helpful way of illustrating the data because we now have lots of totals. We've got the total number of coffee drinkers, total number of tea drinkers, those who didn't drink coffee, didn't drink tea, and the answer to our original question was the total number of people who drank coffee, so that's 22. A completed Venn diagram with two overlapping circles will have 4 numbers. In this example, only tea, tea and coffee, only coffee, and neither. But sometimes the information is not presented in a nice order to enable us to do that. So I'm going to work through the same example again. Imagine you don't know the answers though. So our 36 office workers, we put the total 36 in a box in the corner. 15 had drunk tea. Now notice that's not 15 had drunk only tea, so we need the whole of this circle to total 15. So we'll put that 15 up here to show that it represents the whole circle and not just the only tea drinkers. 22 had drunk coffee, so similarly we'll section off this 22 here to show that the coffee circle needs to total 22, and 6 had drunk neither, so they go out here. Now using this information we can fill in the remaining spaces. 36 takes 6 means that there are 30 people somewhere in the overlapping circles. But if we add the 15 and the 22 together, that's 37. 7 more than the number of people left. So the extra 7 people must be in the overlap. They drank both tea and coffee. Now we can use our numbers that have been sectioned off to work out the missing numbers. 15 takes 7 is 8, 22 takes 7 is 15, and that's the completed Venn diagram.